All right, everybody, I think we're going to get started. Thank you all so much for joining another edition of CircleCI 101. My name is Christopher Black. I am a solutions architect with CircleCI. And in today's webinar, we're going to talk a lot about CircleCI. We're going to talk about continuous integration. We're going to talk a little bit about the philosophy behind continuous integration, continuous deployment, why this is a mission critical activity for organizations of all shapes and sizes. And then we're going to finalize with a demo. We're going to do a live demo. We're going to build, test, and deploy an application end to end, leveraging a lot of out-of-the-box platform features. And then hopefully, if I don't ramble on too much, hopefully if we've got 10, 15 minutes at the end, we're going to open it up for Q&A. All right, that's me. It's a little pixelated. I'm Chris. I'm the solutions architect with CircleCI. I've been with the company for about five and a half years. Some might say that's a lifetime in this industry, but I absolutely love the company. I love the technology, I love the people we work with. I think the problem set associated with continuous integration, continuous deployment is fascinating. First couple of years I was here at the company, I was a site reliability engineer, a humble SRE. So my background is predominantly DevOpsy, infrastructure engineering. I'm known as the Terraform guy in the office. And then about two and a half years ago, maybe a little bit longer at this point, I fell to the dark side and I transitioned into a customer-facing engineering role, which I think is great because I love talking to people about DevOps and continuous integration. I love interfacing with customers. And ultimately, I love helping people and companies of all shapes and sizes build better quality software quicker, more reliably. Quick overview of the agenda today. So like I said, we're going to talk a little bit about the company's history, kind of our mission statement. To me, it's very important. It's one of the reasons why I've stayed with the company so long. We're going to talk a lot about the platform features. I'm going to use the term out-of-the-box features because, spoiler alert, we don't have a plugin-based architecture. A lot of the really powerful build optimization features work right out of the box, batteries included. The ordering here, actually invert items 3 and 4. We're gonna kind of conclude with the demo, and then I believe we're gonna make this presentation available to everybody for posterity. So we're gonna include some resources at the bottom. How do you onboard your first project, your first Hello World program, etc. So without further ado, oh, and of course we're gonna save hopefully 10, 15 minutes at the end for Q&A. So without further ado, let's dive right in. So what is CircleCI and why should you care? Well, spoiler alert, we're a continuous integration company. And we're going to talk here in a minute about why continuous integration, continuous deployment has become a mission critical activity for teams, for organizations of all shapes and sizes. And it's really, really interesting when you think about kind of the history of DevOps and some of the core pillars, some of the core activities associated with the DevOps movement. So, like I said, spoiler alert, CircleCI, we're a continuous integration company. Now, if we go back to the distant past, 10, 15 years ago, let's think about how software was built, tested, deployed 10, 15 years ago. Well, most software applications, big tech, small tech, software in general, generally relied on fairly cumbersome monolithic application architectures. You think 10, 15 years ago when I'm starting to show my age here, when I was still an intern in college, a lot of testing, most testing was still a very manual activity. You had very large QA functions in organizations. In fact, my first job was a QA tester. It's how I kind of got my foot in the door for the industry. I quickly learned the power of Bash and I tried to automate as many activities as I could, but testing was still a very manual process. When you think about what releasing software entailed 10, 15 years ago, well, if testing software was manual, releasing software was a painful experience for organizations of all shapes and sizes. It's one of the reasons why the DevOps movement kind of arose organically in response to a lot of the challenges that many companies were facing. The notion of continuous integration, it's been around for a long time. If any of you have ever read Kent Beck's famous book, Extreme Programming, written in 1999. What he talks about, you could kind of argue, were very much the precursor to continuous integration, the precursor of more automated testing, of automating this concept of a software delivery pipeline. Fast forward to 2006, the landmark book, Continuous Delivery, very much kind of articulated formally what would become the rudiments of continuous integration as a formal engineering practice. I digress. The point is that once upon a time, continuous integration was this kind of niche software practice that only a few companies, a few teams, very forward-thinking, very agile teams practice. I don't think it had yet been ritualized at scale at the organization level. And the lack of continuous integration, of automated testing, et cetera, releasing software, testing software was a very painful, brittle experience. So now we fast forward to the late 2000s, early 2010s, we see the proliferation of web apps, web-first technology. The JavaScript ecosystem starts to explode, starts to take off. A lot of really powerful changes in the industry are afoot. GitHub launches 2010. CircleCI, we've been around since 2011. So a lot of really interesting changes are happening in the industry. And I emphasize these changes in architectural patterns, changes in the way people start to kind of build and test software. So I emphasize all of this to say that now continuous integration starts to become more critical, starts to become more important, the notion of automating tests, the notion of automating your deployment pipeline starts to become a mission critical activity. So we fast forward all the way to the right to microservices. So Docker is an absolute game changer. I'm not going to go on a tangent about the criticality of Docker and containerization technologies in general, but Docker fundamentally changed the way we build, test, and deploy software. It's a fact. Docker also fundamentally changed the way we architect applications. So now we're breaking up our application into a series of discrete microservices. We're leveraging container orchestration technologies like Kubernetes, like Docker Swarm, AWS ECS, et cetera. So now in this paradigm, continuous integration, continuous delivery, continuous deployment is now mission critical. It's the only way you can effectively at scale build, test, and deploy software in this new ecosystem, an ecosystem of infrastructure as code, cloud native technologies, containerization technologies, container orchestration tools. So what was once a kind of hipster niche software practice has now become a mission critical component in how organizations of all shapes and sizes build, test, and deploy software. And if you think about some of the core concepts associated with DevOps means a lot of different things to a lot of different people. We can all agree that automation of all the things, testing, building, et cetera, is a core pillar in the DevOps philosophy. That was a lot. All right, next slide. So CircleCI's mission is to make it as easy as possible to go from idea to delivery. And that effectively means narrowing the distance between idea and implementation. And you do that with rock solid software delivery practices. And so the analogy I always give people is, let's say you're working with a really talented product person or anybody for that matter, and they've got an idea, they've got a really compelling idea, and they say, how quickly, how seamlessly can we get this idea into the hands of customers? That's what narrowing the distance between idea and implementation really means. How quickly and seamlessly can we get this application, this product, this service, this feature into the hands of customers? And when you narrow the distance between idea and implementation, you amplify innovation. You accelerate innovation, I guess would be a better way to put that. So like I said a moment ago, we were founded in 2011. We're currently at 390. I have to constantly update these slides. These numbers are constantly changing. Last time I did this presentation, we were at 350 employees. We're at 390 employees now. We have offices all over the world. We're a globally distributed company, and I think that's a wonderful thing. It just means we're better able to serve our customers. One really compelling example of this is we have a globally distributed support team, and as a function of which we can operate under very tight SLAs for a lot of our customers. We help teams build better software quicker, more reliably. And I think it's safe to say we're currently the world's largest shared CI/CD platform. We've got an amazing rock solid infrastructure. I know I was on the SRE team for a while. And I think it's safe to say we run more builds by an order of magnitude than any other CI platform in the market. The customers, this is just a small cross section of some of the customers we do business with, but you can see here that there's a variety of industries represented. And this is a nice visualization of where we sit in the tool chain. So we sit very comfortably in the middle at the orchestration layer, very comfortably in the middle with source material on the left. That's your version control system, GitHub, Bitbucket, some kind of Git back version control system, and logistics on the right. That's a runtime environment. And a runtime environment can be a lot of things. It could be an EC2 instance, it could be a Kubernetes cluster, it could be, in some instances, physical bare metal infrastructure. It can be a mobile device, it could be a Raspberry Pi. But when you think about the activities, like I said, all the core activities that go from taking source material on the left, building, testing, packaging, et cetera, doing that securely, in a repeatable, deterministic fashion, and then ultimately taking these artifacts and promoting them to different runtime environments. There's a lot of really core activities that go in there. But bear with me, folks. I'm gonna kind of use an analogy here. Rock solid CI principles, it's kind of like, bear with me, good plumbing. You shouldn't have to really think about it. It's there. And so that's where having a rock solid CI system comes into play. In a perfect world, the world obviously isn't perfect, but in a perfect world, developers, end users, they need not think about, okay, managing, build machines, provisioning, build infrastructure. Ideally, like a rock solid Kubernetes cluster, it should just work. And so that's where we come in. So let's talk a little bit more about some of the core features that I think certainly set us apart as a platform. So the first thing I want to talk about is our philosophy of configuration as code. So all of your project-specific configuration is going to be stored as a declarative YAML file that's going to live in repo with whatever projects you're building on the platform. And we think there's a number of very strong benefits associated with this. The first thing that hopefully comes to mind is that if you can put all of your project-specific configuration in version control, you can leverage all of the benefits of version control, all of the same benefits that make version control a very, very, very powerful tool in the context of software delivery, building software, versioning, auditability, sharing, all of it. All the benefits associated with version control you can leverage by storing a configuration file in your version control system. When we talk about project-specific configuration, there's a couple of core things that we're talking about. We're talking about the individual steps that you execute when you run a build. If you're using a pipeline or a workflow, and I'm going to use these terms interchangeably, workflows, pipelines. A workflow is an orchestration of jobs. The classic example is build, test, and deploy, but I'm sure many of you can attest workflows can be a lot more sophisticated than that. The shape of your workflow is going to be defined in your configuration file. If you're running your build inside of a Docker image, well, what Docker image am I running my build inside of? Do I need credentials to authenticate against a Docker registry? I have a private image that I need to pull in as part of my CI process. All of this is going to be defined in your configuration file. And again, we think there's a lot of core values associated with storing all of your project-specific configuration as a declarative YAML file. Configurable resources. Ooh, one of my favorites. So we have this notion of resource classes on our platform. That's the term of our resource classes. You can think of a resource class as a mapping to an EC2 instance. So larger resource classes, larger instances, smaller resource classes, smaller instances. And when we say large or small, what we're really denoting is the amount, the amount of available resources that will be made available to a given build. And when we say resources, what we're really talking about is the number of cores and the amount of RAM. So for large computationally intensive projects, the example I always use is potentially Android, Java, JVM, computationally intensive. You're probably going to want to run that on a larger resource class, right? You're probably going to want to have a couple of cores, a couple of gigs of RAM, et cetera. Let's say you're doing some kind of static code analysis, or let's say you're using Terraform to deploy infrastructure to a cloud provider of your choice. The Terraform binary is basically making a couple of many API calls, but it's just making API calls under the hood. So you could probably run a job like that on a small resource class, for example. The takeaway here, though, is you have the ability to right-size individual resource classes at the job level in the workflow. And this is really powerful. It lends itself to flexibility, extensibility. Some jobs are going to be more computationally intensive, some jobs less so. Of course, all of this is going to be defined in your configuration file. Databases and services. So there are a number of instances where you're running CI, you've got a CI process in flight, and perhaps one of your jobs, and I'm going to use the term jobs. Jobs and builds are very much interchangeable terms. Technically speaking, the job is the term of art. A job is effectively a collection of steps. So there are many instances where you're running a job. That job is going to need to talk to some kind of stateful service for whatever reason, for testing, any number of reasons. It's going to need to talk to some kind of database. It could be MongoDB, it could be Postgres, etc. We have the ability to provision what we call sidecar containers. Effectively, sidecar containers run kind of in the side in parallel to the primary job, and the database service will be exposed via localhost. But this is a very powerful tool. Like I said, there are a number of instances where you're running a build, you're probably going to need to connect to some kind of stateful service for testing, etc. we have that ability on our platform. And of course, this will be defined in your configuration file as well. All right, Docker layer caching and remote Docker, more good stuff. So especially these days, folks are building lots of Docker images as part of their CI process. You have the ability to run builds inside of Docker images. Most of the time, customers do that. I generally recommend running your build inside of a Docker image. I generally think it's best practices. You containerize your application development environment. You throw whatever tools, languages, frameworks, dependencies inside of that Docker image. You run your build inside of that. Great. What happens if you're building Docker images now as a part of your CI process? Well, being able to leverage the benefits of Docker layer caching, let's say those images are starting to get a little bit larger, maybe they're hundreds of megs, perhaps you have a Docker image that you're building that's 1 or 2 gigs. Being able to benefit from Docker layer caching can dramatically cut down on the time it takes to build a Docker image. And when you think about the power of that, what we're doing is we're amplifying the developer feedback loop by being able to shorten the times it takes to build those Docker images. All right, insights and test summary. So as you can imagine, it's very important to have telemetry, to have metrics into your overall CI process. Now that's where the feature called Insights comes in. And Insights is more or less what you'd expect it to be, a lot of powerful build metrics related to your overall CI process. What are some of my longest running tests? How long is my average pipeline duration? How long does it take to execute my slowest job? The kind of metrics and information you'd need to make data-driven decisions when it comes to your overall CI process, where and how to triage resources. I've got this one flaky test. Sometimes it takes, many minutes. How do we optimize? How do we prioritize engineering resources based on the information that we have available? So that's where Insights comes in. We've recently made some significant improvements to the Insights functionality. We have a beautiful graph, we have a beautiful UI where we graph all of this information, but there's also a number of instances where you probably want to extract this information from the API and perhaps run your own analytics on top of it. Perhaps extract this information as a CSV file and throw it into Excel and do some more data manipulation. All of this is possible with the Insights functionality. Yeah, and this is just a nice visualization of some of the stuff you can see, some of the information you can see in the UI. What's really exciting though is that everything you see in the UI, you can also export it via the API. And like I said, to run your own analytics on top of it. All right, interface. We're going to see a lot more of the interface here in a few minutes when I run through a live demo. But as you can see here, we have a very beautiful UI, and a lot of the information you see in the UI is things you'd expect, right? Build output steps. Perhaps we want to see the person who, the entity, the VCS entity associated with the person who triggered a pipeline. We want to see it. You can see here the commit associated with the pipeline, all of that stuff. We also have a very robust CLI, a local CLI tool, which I think is a very powerful tool for a number of reasons. Being able to validate the syntax of your config files, being able to run Docker jobs locally. When we talk about a feature called Orbs, you're able to interface with the Orb registry via the CLI. So I highly recommend all of you, if you're kicking the tires on the platform, stop, pause the video, download the local CLI. It's a really powerful tool. I highly recommend it. And of course, API, we have a very, very, very robust API. More or less, all of the actions that you can take in the UI, you can do with the API as well, which just lends itself to more automation. Another really exciting feature, let's say your jobs fail for whatever reason. It happens, it's part of the CI process. In fact, there's a lot of value in failed jobs and failed builds, right? That's how we know, what code to fix, where to refactor, things like that. Well, there are many instances where having the ability to rerun job with SSH, being able to SSH into your build environment, to poke around, to look at log files, can be extremely valuable. So that's another really important feature I want to highlight. That functionality works right out of the box. What we do is that we automatically inject the default key pair associated with your SSR. We automatically inject the default key pair associated with your VCS account. There are a number of instances where maybe you want to associate an additional SSH key pair to use for authentication. Totally possible, also controlled in your configuration file. All right, Orbs. Orbs, one of my favorite features to talk about. Orbs effectively are shareable templatized pieces of CircleCI configuration. So we're not a plugin-based architecture, and we think this is a very core part of our value proposition in that, like I said before, CircleCI works just right out of the box, batteries included. That means you don't have a ton of plugins to maintain, to manage, to set up. And also, for what it's worth, plugins can also generally have some pretty gaping security vulnerabilities associated with them. But plugins, on the other hand, can also enable integrations with third-party tools and services. So how do you get that same behavior on the CircleCI platform, Orbs? Orbs are great because not only can you dry up your code for, obviously, encapsulating and repeating common patterns, et cetera, is highly beneficial, but being able to pull in an orb with some prepackaged configuration, orbs are very much the integration point for third-party tools and services. So being able to pull in an orb, let's say a Slack orb, for example, you want to have a custom Slack notification. In fact, in the demo I'm going to run through here in a few minutes, you're going to see a couple of orbs in action. So rather than writing all this boilerplate config from scratch, I simply pull in the orb, I pass in a couple of parameters, I'm good to go. So orbs, I guess in some, are great for integrating with third-party tools and services, but they're also great for just drawing up your code and encapsulating common patterns and paradigms. And here we get a nice visualization of what orbs look like within the config file. And again, you're going to see it's YAML all the way down, simple declarative YAML-based syntax, but we're able to templatize and share these different templates with various jobs, with various projects. And so our orb ecosystem, so when we built the feature, when we launched orbs about a year and a half ago, what we found happened kind of organically, which was really exciting, was that a ecosystem of third-party tools and plugins, everything you can imagine, AWS orbs, Terraform orbs, static code analysis, security scans, the ecosystem for orbs is pretty extensive. So I highly recommend checking out some of the orbs that we have available. And again, if you're looking for a nice seamless way to integrate with some of the tools you see listed here, you merely pull in the orb, you pass in a couple of parameters, maybe an API token, you're good to go. All right, now things are getting a little bit more interesting here. So parameterization in matrix builds. Parameterized config. So the ability to pass in build parameters via the API can be extremely powerful when you're thinking about more sophisticated pipelines, more sophisticated workflows, when you're thinking about automating deployment, for example, or more or less having more granular control over your CI process. The ability to pass in build parameters. A good example of build parameter might be run extra tests. You might parameterize your deployment target, for example, but being able to parameterize builds and jobs gives developers more granular control over the steps and the activities into their CI process. And when you think about more extensible workflows, again, workflows, pipelines, these terms are interchangeable. When you're able to have conditional logic within your workflow stanzas and you're able to pass in build parameters, at that point, it opens up the surface area of the platform for much more sophisticated automation, much more sophisticated continuous deployment, continuous delivery practices. It's a really, really exciting feature. Highly recommend you check it out. And then, of course, matrix builds. Matrix builds is really interesting. It's one of the newer features we shipped in the past year or so. But basically, hopefully you all can see my mouse. You can see the cursor. But if you look under build parameters, let's say you're testing multiple languages under multiple operating system types. This here, it might not be the most compelling example, but you're testing multiple languages over multiple browser versions, for example. What you do here is you pass in an array, 2 arrays, in fact, an array of operating systems, an array of different language types, maybe multiple versions of Go, et cetera. And what we do is there's some cool syntactic sugar that goes on under the hood where we'll automatically create a Cartesian product, and we'll be able to put together a matrix, if you will, of the various job types, the various language types, et cetera. You could probably do this on your own with build parameters, but this just adds some nice syntactic sugar to that methodology. Now, you can't talk about a cloud-native CI platform without talking about security. And really what this means is some security features and more or less our security posturing at large. So we have a powerful feature, we call it context, not to be confused with Kubernetes context, but context are effectively shared groupings of environment variables that are set at the org level. And so what we do is we mount these contexts, we mount these groupings of secrets to individual jobs in our pipeline. And so a classic example, a good example, I think would be the classic build, test, deploy scenario. And so at some point when we're deploying an application somewhere, we're promoting a release candidate from one environment to the other, we're probably going to need some kind of secrets, some kind of API tokens, some kind of credentials, SSH keys, some kind of authentication mechanism to take our artifact and to drop it into, from one environment to another. And so in that example, build, test, and deploy, the build and the test jobs, the build and the test stages need not have those secrets. There's no reason for those secrets to be present in those runtime environments. We're thinking, when we're thinking about security, we're thinking about isolation and segregating our concerns. And so what we would do is we would mount a context, maybe we'll call that context AWS pre-prod, right? Very contrived example, but hopefully you all get the point. We would mount that context with a shared grouping of secrets to the deploy job. And really what that means is that then the build and the test stages, those secrets wouldn't even be present in the runtime environment. And again, context are set at the org level, which is a really powerful feature. And then we mount these contexts to individual jobs in the pipeline. And of course, when you think about very bleeding edge security practices like automatically rotating context, automatically updating our security credentials, automatically rotating keys and things like that, being able to do that with the API and the CLI lends itself to that kind of automation. And so we have a number of prominent security certifications. The big one obviously is SOC 2. It's really important for a company at our stage to be SOC 2 compliant, but you're going to notice another very prominent security certification on the lower left. And that security certification is called FedRAMP. And the best way I can describe FedRAMP is it's very much like SOC 2, but specifically for the federal space. And so we do business with a lot of federal entities. Fun fact, the US government is in the midst of a great digital transformation themselves right now. A lot of organizations, many federal agencies are also trying to modernize how they build, test, and deploy software. And so by virtue of that, we underwent something called a FedRAMP authorization or certification, very much like SOC 2, conceptually very similar to SOC 2. A lot of the same kind of activities and audits went into the FedRAMP authorization, but that means that we're authorized to do business in the federal space. And I think that's a very telling indicator of where we are in terms of our security features, our compliance, and our overall posturing. Before I go to the next slide and talk about a few other features, I guess it's really important to talk about at a super high level, when folks run builds on our platform, you're going to run your build in one of two environments. It's either going to be a Docker image or it's going to be a virtual machine. We're going to check out the code associated with the project that we're building, obviously, and that code is going to come from a get back version control system. So we're going to check out the code using a set of read-only SSH keys. Now we're going to execute whatever arbitrary commands are specified in the config file, and then we're going to destroy that environment. We're going to destroy that environment. We're going to destroy anything inside of that environment, anything in that environment that has not been explicitly persisted to an artifact storage service, anything that hasn't explicitly been deployed, anything that hasn't explicitly been cached is going to be destroyed. It's going to be completely destroyed. Now, these environments are isolated both at the network level and at the C group level. And that is to say the individual processes themselves are isolated. And so what that means, obviously, the inherent benefits of a deterministic repeatable environment, but it's also a very secure environment. So every time you run a build, it's going to be ran in a container or a VM. We're going to execute your steps, and we're going to destroy that environment. We're going to destroy the source code. We're going to destroy the environment itself, et cetera. And so I want all of you to kind of think about those series of activities as it relates to our overall security methodology on the platform. All right, test parallelization. I don't know, for whatever reason, I always struggle with this word. There's a lot of letters there, but concurrency and parallelism is when you have a very large suite of tests and we need to parallelize. God, I don't know, I really do struggle with that word, but we need to split those tests into various nodes in a cluster. So let's say, contrived example, we have 100 tests that we want to run. Well, if we were to run these tests in serial, it could take, let's just say 10, 15 minutes to execute all those tests. Not the end of the world. Let's say we're building a really large Rails project, for example, a lot of automated tests. 10, 15 minute overall build time. Not the end of the world, but if we could shorten that build time, if we could amplify that developer feedback loop, if we could potentially split some of those tests up to various nodes in the cluster, it would behoove us to do so. And so that's where test splitting and parallelization comes into play. The ultimate benefit being faster build times. There's a couple of ways you can go about parallelizing your test in the platform. There's a couple of ways you can go about parallelizing your test. The most common way, though, is we have a local CLI that we inject into the build environment. And you're going to specify a couple of parameters on how to split up your test, maybe based on file name, maybe based on class name, maybe based on file size. If you store your test results JUnit XML style, not only will we automatically, we'll display that in the UI, we'll put some pretty formatting in there. I think it's a valuable feature. You should all store and persist your test results. What we'll do is we'll take that information, we'll take that historical test timing data, and we'll use that to intelligently split your tests in the future. And so perhaps a buzzword associated with that is intelligent CI/CD, but as you can imagine, the more builds you run, the more accurate that test timing data becomes, the more evenly we'll parallelize those builds, the more efficient your CI process will become over time. All right, workspace and caches. So there's a number of different caching methodologies, strategies, and tools we have on the platform. I guess kind of the long and the short of it is we have first-class dependency caching. And so as you can imagine, that will dramatically speed up your overall build time. A good example of dependency caching, node modules. Great example, node modules. Node modules are ubiquitous. Node modules can, take up a lot of space on the file system. And above all, when you're, as you can imagine, let's say you're running a node project, you're building a node project, each and every time you run a build, you've got to pull in all of these modules. It's not super deterministic, and it could probably take a little bit of time. And so if we can cache any of these modules, for example, we can speed up our overall build time, and we can make the builds a little bit more deterministic. There's a couple other features here. Let's say you have a workflow, a pipeline, multiple stages. We also have a functionality called Workspaces, which enable you to persistently share files across various stages in the workflow. You can think of that as a kind of temporary caching that's applicable to the lifetime of a single workflow run. And then, of course, we have a first-class artifact service, but many folks generally leverage something like S3 or Artifactory, for example, for persistent long-term file storage. All right, how are we doing on time? Great. So approval jobs. As many of you can probably attest, even in organizations with very sophisticated and mature DevOps practices in play, very mature, sophisticated automation, oftentimes there's regulatory compliance, or there's something that says, hey, look, before we can promote an artifact from environment A to environment B, somebody, a team lead, an engineering manager, an ops person, an SRE has to explicitly approve that deployment. And that makes a ton of sense. Another really good example of an approval process would be Terraform. You might want to run the plan stage separately and then actually have somebody explicitly click approve before applying any infrastructure using an automated tool like Terraform. It just makes sense. And so, of course, this would be configured in your configuration file. And then, of course, we have the ability to approve the process via the API as well. So you can imagine maybe you get like a Slack notification that says, hey, we've got this deployment job pending approval. Team lead takes a look, they click approve with the Slack bot, makes the API call, the deploy job runs. All right, I've been talking a lot, but we still have a demo in store for everybody. So I'm just gonna switch screens here. And remember, we are gonna save, hopefully, how are we doing on time? Great. I'm going to try to blast through this in 10 minutes. So we have time at the end for Q&A. Hopefully all of you can see this okay. I recently started using the dark theme on GitHub. It's kind of hipster, it's kind of niche. I really hope you can see this all okay. I'm a big fan of the dark theme, but let's just talk about what we're actually going to demo for the next couple of minutes. So we're going to build, test, and deploy an application end to end. It's a simple Node.js application. And the reason why I'm using a very simple Node.js application with an Express backend is really it's designed to be a vehicle, to have a meaningful conversation of a day in the life of a developer using CircleCI. We're going to deploy this application to Heroku, and we're going to do this leveraging a lot of out-of-the-box features that I just spent the past half hour talking about. And these are things like Docker layer caching, test splitting, etc. So I start with a pull request I have in flight because our integration at the VCS level is very powerful. And generally speaking, for most developers, the entry point for our platform is, somebody just pushes some code, they push some code up to GitHub, maybe they've got a PR in flight, it triggers a CI process. My build has failed, And so obviously as a developer, I want to find out why my build has failed. You can see in my commit message, these new endpoints are amazing. I'm trying to be funny. Sometimes my jokes land, most of the time they don't. But we can see here very clearly within the pull request that my build has failed on Circle. And so as a developer, I obviously want to find out why. And so by clicking details, we're automatically redirected to a jobs page on Circle. Now, hopefully it's not, but I assume that for many of you, this is probably the first time seeing a CircleCI, seeing the application itself. I'm actually going to do this slightly out of order. These are all steps that I specified in my configuration file. We spent a bit of time talking about the importance, the criticality of a config file. And so these are all steps that I specified in that file. Fetch dependencies, save cache. We were just talking about caching, test splitting or test application, leveraging test splitting, for example. But what we see here is that one of our tests has failed, right? So this is kind of the meat and potatoes, if you will, of continuous integration. We really want to find out what's going on with the failing test. So I can see the stack trace associated with that failing test. And what we see here is a very simple assertion statement failed. Okay. Now, if this were a more complicated project, for example, if the test failure was a little bit more nuanced, maybe a little bit more esoteric, I would SSH into this job. I'd look at log files and poke around. But to me as a developer, simple application, the test failure is very clearly indicated within the UI. Great. So as a developer, armed with this newfound knowledge, I know why my assertion statement failed. I'm actually going to fix my broken test. Yes, I am using GitHub's online text editor, probably not best practices in the real world. I generally make a joke about this. I've got an old ops manager who probably would agree with me that this isn't best practices. I think we'll be okay for today. Okay, awesome. So this is our assertion statement right here. I am going to, what branch am I on? Okay, well, perfect. So commit directly into the update API test branch. Yes, we're going to commit this directly into the feature branch itself. And so the default commit trigger on the platform is we're going to run a build, we're going to run a pipeline on every commit. There's a number of instances where you probably don't want to run a build or a pipeline on every commit. Maybe you want to have some kind of branch level filtering. Maybe you only want to run a build on PR. Maybe you have a small subset of jobs that you want to run on a particular Git tag. All of this is possible. All of this is configured in your configuration file, but for a very simple kind of one-off project like this, we want to build on every commit. And so by committing that directly into the feature branch itself, we kicked off another build on the platform. Awesome. Okay, so we did just trigger a workflow. And as you can see here, we get a nice visualization of the shape of that workflow. And this is what I mean when I talk about the shape of the workflow. The classic example, build, test, and deploy, that's fairly straightforward. What we have here is a pipeline with several stages. And some of these stages, I've given nice kind of meaningful semantic names to all of these stages, but build node app, code coverage, vulnerability scans. Once all of these jobs, once all of these stages pass, we're going to build a Docker image. If it looks like some of these stages are running really, really quickly, that was very much by intent and design. It might come as a shock. I over-engineered the heck out of this simple Node.js application, but we're also leveraging a lot of powerful features, build optimization features. And so, for example, build Docker image down here while I'm leveraging Docker layer caching, right? And so that's why we're able to build a Docker image, and this should take a minute, maybe less than a minute, 35 seconds. That's pretty fast. That's pretty fast. And the reason why we're able to build a Docker image in less than a minute is because I've leveraged a lot of these out-of-the-box build optimization features. And so let's click on this job and get a little bit more visibility into what's going on. Great. Green checks all the way down. This is exciting. This is what I'm looking for as a developer. Again, these are all steps that I specified in my configuration file. And then we have other pertinent information at the top here. Executor, Docker medium. So this job is running with 2 cores and 4 gigs of RAM. And you'll see a little bit later in the workflow, we're going to run actually one of these jobs on a small resource class. In fact, when we do the deployment itself, we're going to run that on a small resource class because the deploy job is just making a couple of API calls. I can see the author and the message associated. So the person who actually triggered the commit, which kicked off this build, we could see, there I am. We can see the commit associated with this pipeline, in fact, which would take us back to GitHub. And of course, we can see the time it took to execute this job. So let's go back to our workflow. Okay, look at that. So our entire workflow took 2 minutes and 44 seconds. That's really, really fast. Let's go back to our pull request. Boom, look at that. Beautiful green check. And when I click show all checks, every one of these corresponds to an individual job or stage in the workflow. And this is powerful because it just gives us more granular visibility into our overall CI process. So green checks all the way down. It looks like all of our tests have passed. We built a Docker image. This is terribly exciting. I'm confident in the quality of my application code. This is the essence of good continuous integration. I'm confident in the quality of my application code. I think I'm going to merge this into master. Voila. All right. Now, we're not quite done yet because by merging this pull request into master, this is going to trigger another pipeline. The shape of this pipeline, the shape of this workflow is going to be a little bit different. I'm going to show you here in a second. Date API test. Great. Okay. So we're going to filter to the master branch. Super, super fast. All right, this is great. So let's click on this workflow. Okay, amazing. So hopefully all of you have noticed that the shape of this workflow is slightly different than the other. And that's for a couple of reasons. The primary reason is that we're running this on the master branch. And like I said before, there are times in which we might want to modify the behavior of the workflow, the pipeline, based on things like git branch or git tag. And so this workflow is a little bit different because we're dynamically provisioning a small Heroku environment, and that's fine for a small one-off project like this. If this were a more complicated application, I'd probably be using something like Kubernetes or ECS. But for a simple one-off project, I think Heroku is a fabulous choice. We're provisioning a Heroku environment. Once all of these stages pass, myself, somebody on my team has to explicitly approve this deployment. And then we've encapsulated all of our deployment logic into this stage down here at the end. This stage down here at the end, spoiler alert, it's running on a small resource class because it's really just pulling in the Heroku CLI, making a couple of API calls, etc. Let's go back to the build Docker image job. Should take another moment or so to run, but let's take a quick gander at the configuration file. So talked about it before, simple declarative YAML syntax. And so this controls everything from the shape of the pipeline, the steps that we execute. You can see here, I'm pulling in an orb. So at the end of this, we're going to get a nice custom Slack notification. I'm able to do that with a really cool orb that alleviates a lot of the kind of boilerplate associated with like building a custom Slack notification. So I pull in the orb, I pass in a couple of credentials, one of which being my Slack token. I'm good to go. I generally recommend this as best practices, especially for folks who hopefully at the end of this video are super fired up. They're ready to take CircleCI to their organizations and hopefully evangelize it with some of the other engineers you all work with. I generally recommend this as best practices. Put your workflow stanza at the top. It makes the config file significantly more readable. Doesn't really affect the behavior of the pipeline, but some folks put it at the bottom. I personally recommend putting it at the top because as a developer, if I'm taking a look at a config file, the first thing I want to see is just kind of the overall shape of the pipeline, and then I want to drill a little bit deeper into the job level. So I've got my workflow stanza up here at the top. For the deployment credentials I use, that's how I mount that context to the deploy job. That deploy job is only going to run on the master branch, and then these are the individual jobs themselves. And so you can see here, these are the individual steps that these jobs execute when they run. Okay, let's go back to the workflow. Okay, look at that. So I'm going to approve this deployment. And when you think about traceability, auditability, it's really pertinent to have the person who actually has explicitly approved the deployment to see that person's icon within the workflow visualization itself. Amazing. And so then everything we see here is redirected from standard out. All of the, everything from standard out and standard air is being redirected to the console, in addition to some of the other stuff you see in the UI. We're pulling in the Heroku CLI. We're going to pass in a couple of parameters, and then we're going to execute a deployment script. So I've encapsulated all of my deployment logic in a simple shell script. Most of the time, that's what a lot of customers do on the platform. Same concept is applicable to Kubernetes and Helm, for example. You'll probably have a Helm chart, and then at some point during your pipeline, you're going to apply those changes to a Kubernetes cluster, for example. The same principles are very much applicable. But you'll notice, like I said a moment ago, that we're running this on a small resource class. And again, this is because this job isn't running any tests. We're not building a Docker image. It's not very computationally intensive. We're really just pulling in the Heroku CLI, executing that script, deploying our application. Let's see what's happening here. Cool, updating NPM. One thing to note, because we are pulling the Heroku CLI in, and you see it took 46 seconds, excuse me, not the end of the world, but what I would probably do if this were more kind of a production-like environment, maybe a larger, more complicated application, I would probably produce a custom Docker image. And like I said earlier, I would just throw whatever languages, tools, frameworks, CLIs, dependencies, et cetera, into that Docker image. And so that way, every time I ran a build, I would have that stock Docker image as my primary executor with all of the tools I needed to build an application inside of it. Cool. As you can see, this is happening super fast. And then if all goes as planned, hopefully the demo gods are with me today, we'll get a nice custom Slack notification that'll indicate that we've successfully deployed our application. Boom. Okay, so this job executed 2 minutes. Amazing. So we did just get a custom Slack notification, including a link to the application we just deployed. Well, there we have it. I always make this joke, if the branding seems a little bit off, I'm not a front-end web developer. These are some of the really talented, amazing people I work with. These are some legit customer testimonials. And then lastly, let me see if I can build info. I've also injected a lot of pertinent kind of meta build information in the form of environment variables and tagged this application. So things like the username associated with the person who ran the pipeline, the build number associated with this deployment, and then last but not least, a link to the deploy job itself, which just lends itself to that kind of end-to-end traceability from commit to deploy. Okay. Okay, let me, Slack is being, Zoom is being funny. All right, cool. Well, that was the presentation at the demo. I think I did okay on time. We have 11 minutes left. I threw an absolute ton at everybody. We talked about the history of the company, a lot about our mission statement. I think I went on a small rant about kind of the history of continuous integration, the importance of continuous integration, continuous deployment in today's ecosystem. I would love to answer any and all questions you have. Again, I threw a ton at everybody. Happy to answer any questions, anything at all. All right, so I'm just going to go, I'm starting from the top. So Nick Morozov asks, are there any plans to implement UI form for input parameters for triggered workflows? Okay, great question, Nick, great question. So to summarize what Nick asked if there's a way to input build parameters from the UI. That's actually a really, really good question. To my knowledge, I don't think so at this point in time. What I would recommend everybody do is check out discuss@circleci.com. We have a number of ways to funnel feature requests to our product team. Our product team is very active on the community forums. And so any and all feedback, any and all suggestions for how to improve the platform, we're certainly all ears. Nick, seriously, very good question. I do think there would be a lot of value, in fact, in having the ability to input build parameters in the UI. As it stands today, it's all done via API or CLI, but wonderful question. And then Nick asks another question. how can I restrict the list of users who can approve a particular CircleCI job? Now that is another very, very good question. What you're actually going to do is you're going to use a feature called restricted contexts. So you can't configure who can actually click the approve button, but the real value isn't configuring who can click the approve button. It's who has access to the secrets that the deploy job or whatever job that comes after the approval step have in the execution environment. That's where you're going to leverage a feature called restricted contexts. Restricted contexts are going to leverage the GitHub Teams functionality and API. And so what you'll do is you'll restrict a context to a particular team or a particular subset of individuals, if that makes sense. More questions, thoughts, comments, musings. Hopefully all of you found this valuable. Well, Uziel Bueno. Oh, you're very welcome, Nick. Thank you so much for asking two great questions. And again, I would check out discuss.circleci.com. I would check out the forums. Seriously, our product folks are constantly looking at that. And we're actively soliciting feedback on how to improve the platform. I think that's a great feature request. Uziel Bueno commented, wow, looks awesome. Thanks, it means I've done my job. Final call for questions, comments, musings. How do I get started? We have a very generous free tier. Everybody on GitHub or Bitbucket gets access to a free container. So I highly recommend if you're new to the platform, if you're new to continuous integration, if you're new to Circle, take advantage of that free tier. If you've got a simple one-off project, maybe an open source project you're working on, if you just want to kick the tires on maybe a sample application, highly recommend you do so. Take advantage of that free tier. But awesome. I certainly hope all of you found this valuable. Thank you all so very much for joining. If there are no other questions, I'm going to drop off. We're going to make the presentation materials available for all of you with some getting started resources. But I want to thank you all for joining. Bye.